There is grandeur in this view of life.
Welcome to Evolution Talk with Rick Coast, an introduction to the oldest story ever told.
Way back, many episodes ago, we looked at the formation of the first complex cells, the eukaryotes. Now, these are cells with a nucleus, and their emergence has been thought to coincide with an early oxygenation event or events on the Earth's surface. Now, the emergence of these complex cells is known as eukaryogenesis. It's also been believed that a primitive cell, a prokaryote, happily floating along a primordial ocean, bumped into a primitive bacterium. Instead of floating away, the primitive cell decided it was time for lunch and engulfed the bacterium. Now, the bacterium didn't fight back, but it wasn't easy to digest. So instead, it became part of the primitive cell. It became the cell's powerhouse known as the mitochondria. As much as everything I just said seems to fit the bill with how prokaryotes went from a simple cell to a eukaryotic complex cell, there's a problem with the theory. When you consider the fact that early prokaryotes, the very ones floating around the ocean bumping into each other, lacked the ability to engulf one another, the theory implodes. So, how did eukaryotes emerge? Eukaryotes do possess the ability to lunch on one another, but they have mitochondria already. So, if that's the case, where did the mitochondria come from if not from an ancient struggle for survival? For that answer, we have to make our way to a very dark place that we've only known about since 2008. It exists on the edge of Asgard. Not that Asgard. This Asgard, is deep beneath the Atlantic Ocean between Greenland and Norway. It is known as Loki's Castle. Now, Loki's Castle consists of 5 hydrothermic vents known as black smokers, and that's because they look like black chimneys emitting black clouds of smoke. The clouds consist of sulfur and other materials, and it's not a very hospitable place to live. But there is life there. And this life thrives in these extreme environments, especially like the one Loki's castle formed in. And to top it off, we've only known about this life since the 1970s. They are known as archaea, another single-celled organism that lacks a nucleus, thus making them prokaryote as well, or prokaryotes as well. The ones that thrive in the harsh environment of Loki's castle are known as Lokiarchaea. And what do they like to subsist on? Hydrogen. So in those early days before complex cells evolved, we can imagine a hardy group of archaea thriving around a thermal vent just like the Lokiarchaea do today. Craving hydrogen and carbon dioxide, they may have encountered bacterium which produced both of these things through anaerobic respiration, meaning that no oxygen is required. Now, because they couldn't engulf one another, and they both produced something the other wanted, they might have sidled up to one another, exchanged numbers, and decided to stay together. Love finds a way. So in a nutshell, these two ancient microbes, the archaea and the bacterium, joined forces. The bacterium became a part of the archaea. The bacterium lives off of the archaeon's waste and provides it with energy. What I've just described to you is the hydrogen hypothesis. Now, this hypothesis for the rise of the eukaryotes is also supported by DNA evidence as well. The DNA of a cell's mitochondria is different than the DNA of the cell that it's part of. Now, that's how we know it was once another organism. Biologist Lynn Margulis was a champion of the idea of symbiosis, even going so far as to say it was more significant than natural selection when it came to the evolution of life. A pretty bold statement. Now, here she is being interviewed in 2004 by Jay Tishfield, the then chair of the genetics department at Rutgers University.
Random mutation, of course, does play a large role in evolution, but the concept is that random mutation is never enough to go from one species to another, random with respect to selection. So random mutation, changes in DNA, of course, can be documented. They exist all the time. But what we're saying here, and we have lots of documentation, which I'd love to tell you about, is that when you get something really novel, that is a new species, a new organ, new tissues, new organelles, new features in evolution, it's never by random mutation. If you take a Drosophila and you mutagenize it with a chemical mutagen, an X-rays or something like that, you get a sick Drosophila, you don't get a new species of Drosophila. On the other hand, what's been shown very recently is that if some of these insects actually acquire mycoplasmas or other Wolbachia-type bacteria, they can, in one fell swoop, now metabolize new nitrogen compounds. In just the acquisition and integration of bacteria will change that insect dramatically.
In 1966, she wrote a paper titled On the Origin of Mitosing Cells. Now, that paper didn't make the splash she'd hoped at the time. Margulis was a young student faculty member at Boston University when she wrote it, and she was resilient. Her paper was rejected 15 times before it found a journal willing to publish it. She unfortunately passed away in 2011, but I can only imagine how thrilled she'd be to know if you look at mitochondrial DNA, there's a close resemblance to the DNA of the Asgardian archaea found at Loki's castle. It seems that Loki, the god of trickery, has been found out. And that's the wonderful thing about science. It's self-correcting. What we believe to be the way something is today may be upended tomorrow as we gather more data. We only learned about the existence of Loki's castle a little more than a decade ago, and it's turned out to be a wealth of information. Now, Charles Darwin didn't present the world with his theory until 1859. In the grand scheme of things, that's not very long ago. I have a small family graveyard in my backyard, not my family, with headstones that predate on the origin of species by a quarter century. Since Darwin's theory changed everything, it's been poked, it's been prodded, disputed, and added to ever since. It's also the prevailing theory with a lot of supporting evidence for how life evolved on our planet. While we may not yet know exactly how it started, the answer may be just around the corner, or a couple of discoveries away. I hope you enjoyed today's episode of Evolution Talk. I'm Rick Coast, and you can find show notes and source material used for this episode at evolutiontalk.com. I hope your week is going well, and until next time, please take care of yourself.
Evolution Talk is a Rick Coast production.